All right, I'm going to show you guys how I use Google Gemini to study for my exam. So let's get right to it. Hey, are you still there?
I'm doing well. Thanks for asking. I'm glad we could clarify the difference between Q tests and Tucky's HSD test. Is there anything else I can help you with today?
Yeah, so now I just want to make sure that I've gotten all of the information that I'm supposed to answer in this question correct. Will you be able to help me with that?
Absolutely. Let's recap. A priori tests are planned before data collection based on specific hypotheses. Post hoc tests are used after data analysis to explore findings. Examples include Tucky HSD, Bonferroni correction, and Chaffe's test. Q tests are for identifying outliers, not post hoc comparisons. Does that all sound right to you?
Yes. Now let me repeat it back to you.
Great. You've got to stop. Sure, go for it. Ready to
Okay. So a priori tests are meant to um, assess the information that you are hoping to find a result for. In other words, they happen beforehand, before you do the test. And the post hoc tests are for finding significant relationships in your data after an omnibus test, like an ANOVA test. For the a priori tests, that includes the Dunnett t-test and the independent or paired samples t-test. And the post hoc tests include Bonferroni, home Bonferroni, FDR, um, Tukey's test, Tukey's HSD, and uh, Sheffey's test. Is that correct?
Almost. You correctly listed the post hoc tests, but the t tests you mentioned are not a priori tests. They are used for comparing two groups and can be used in different designs. A priori tests are planned comparisons or contrasts, which are specific tests designed before data collection to test hypotheses about specific group differences.
So
Does that make sense?
is a t-test not an a priori test?
That's right. A t test is not an a priori test. T tests are used to compare the means of two groups, while a priori tests are planned before data collection to test specific hypotheses about group differences. You're doing great.
Okay, let me try again.
Okay, take your time. I'm here to help.
Okay, a priori tests are for um, comparisons of data that you know you're looking for. In other words, they happen before the omnibus test. Post hoc tests are for finding relationships in your data after you've already done the test. The a priori tests include planned contrasts, and the post hoc tests include t-tests, Sheffey's test, um, HDR, which is Tukey's HDR, um, FDR, Bonferroni, home Bonferroni, and um, Q tests are something different. Sorry. So yes, that would be it.
You're almost there. You've got the a priori test right with planned contrasts. However, t tests aren't post hoc tests. The rest of the tests you listed, Sheffis, Tucky's HSD, FDR, Bonferroni, and home Bonferroni, are indeed post hoc tests. Q tests, as you mentioned, are for identifying outliers.
Right. Okay, so t-tests are comparing two groups ahead of time, correct?
No, t tests are used to compare the means of two groups, but they're not considered a priori tests. A priori tests are planned comparisons or contrasts, which are specific tests designed before data collection to test hypotheses about specific group differences.
So
Does that make sense?
a t-test is planned, but it happens after.
T tests aren't planned in advance like a priori test. And they're not used after an omnibus test like post hoc tests. They're their own thing, used to compare two groups and see if there's a significant difference between them.
Okay, so just like Q tests, they're not in either of these categories.
That's right. T tests, like Q tests, don't fall into either of those categories. They're used for specific purposes outside of the a priori versus post hoc framework. You've got it.
Okay, let me just repeat this back to you one more time to make sure I get it correct.
Of course, please do. I'm here to help.
Okay, a priori tests are used to examine relationships that are planned ahead of time and post. Wait, was that correct, first of all?
Yes, that's correct. A priori tests are used to examine relationships that are planned ahead of time.
Okay, can you help me find the best way to phrase that if I were to write it on an exam?
Okay, here's a good way to phrase it. A priori tests, such as planned contrasts, are used to examine specific relationships between variables that are hypothesized before data collection. How does that sound?
That was good. Can you repeat that again?
Sure. A priori tests, such as planned contrasts, are used to examine specific relationships between variables that are hypothesized before data collection.
And what about for post hoc tests?
Here's a good way to phrase it. Post hoc tests, such as Tukey's HSD or Bonferroni's correction, are used to explore relationships between variables after an omnibus test, like ANOVA, has revealed a significant overall effect.
Can you say that again?
Sure, post hoc tests, such as Tukey's HSD or Bonferroni's correction, are used to explore relationships between variables after an omnibus test, like ANOVA, has revealed a significant overall effect.
And does that overall effect come from the F critical compared to the F value or from the eta squared value?
The overall effect in ANOVA is determined by comparing the F statistic to the F critical value. Eta squared, on the other hand, measures the effect size, indicating the proportion of variance in the dependent variable explained by the independent variable.
Okay, let's see if I get this right now.
Okay.
So, a priori tests examine the relationships between variables before that are hypothesized before data collection. Post hoc tests examine relationships in variables after an omnibus test, like in ANOVA, and uh, that ANOVA has yielded a significant result. The examples for each include planned contrasts for a priori tests and Sheffey's test, Tukey's HSD, FDR, Bonferroni, and home Bonferroni for the post hocs.
Great job. You've accurately summarized the key differences between a priori and post hoc tests, and you've provided excellent examples of each. Is there anything else you'd like to explore, or are you ready to move on?
Oh no, we're not ready to move on. We're going to do that till I can't get it wrong, which means 3 times in a row with no mistakes.
Okay, I understand. We'll keep practicing until you feel completely confident. Let's try summarizing the differences between a priori and post hoc tests. Again, focusing on the key points we've discussed.
Cool. A priori tests examine the relationships between variables that are hypothesized before they are before the data is collected. The post hoc tests examine relationships in variables after an omnibus test, like an ANOVA, has yielded a significant effect or has shown a significant effect. The examples for each include planned contrasts for a priori tests and Sheffey's test, Tukey's HSD, Bonferroni, home Bonferroni, and FDR for post hocs.
You nailed it. That's a perfect summary of the differences between a priori and post hoc tests. And you've given great examples. Are you ready to move on?
Nope,
Or
one
would
more
you like
time.
to?
One more time.
Okay, let's go for it one last time. You've got this.
Okay. A priori tests examine the relationship between variables uh, that are hypothesized before data is collected. Examples include planned contrasts. For post hoc tests, they examine the relationship between variables after an omnibus test has shown a significant result, and examples include Tukey's HSD, FDR, Bonferroni, home Bonferroni, and uh, I can't remember. Sheffey's test.
Yes, Sheff's test is another example of a post hoc test. You've got it.
Okay, now I'd like to elaborate on the comparisons of power between a priori and post hoc tests and the risk of type 1 error.
A priori tests generally have more statistical power than post hoc tests. This is because a priori tests are focused on specific comparisons, while post hoc tests are exploratory. However, a priori tests don't control for type 1 error as well as post hoc tests, so there's a higher chance of finding a false positive. Does that make sense?
Can you say that again?
Sure. A priori tests generally have more statistical power than post hoc tests. This is because a priori tests are focused on specific comparisons, while post hoc tests are exploratory. However, a priori tests don't control for type 1 error as well as post hoc tests, so there's a higher chance of finding a false positive.
Okay, and for all of the different examples now of the post hoc tests that I gave, including Sheffey's test, Tukey's HSD, Bonferroni, home Bonferroni, and FDR, tell me how they um, account for family-wise error.
Okay, here's a quick rundown. Chef's test is the most conservative and has the lowest power, but it's great for controlling family-wise error rate. Techie's HSD is less conservative and more powerful, but still good at controlling family-wise error rate. Bonferroni and home Bonferroni are even more powerful, but they can be overly conservative, especially with many comparisons. FDR is a bit different, as it controls the false discovery rate rather than the family-wise error rate.
So, in other words, what's the relationship between power and strictness? Is there an inverse relationship?
Yes, that's correct. There's an inverse relationship between power and strictness. As the tests become stricter in controlling for family wise error, they generally lose statistical power.
Okay. Let me just reiterate all of that in order of which post hoc tests are the most powerful.
Okay, let's go through the post hoc test in order of power. Tucky's HSD is generally the most powerful, followed by Bonferroni, home Bonferroni, and then shifts. which is the least powerful. FDR is a bit different, controls the false discovery rate rather than the family-wise error rate.
Okay. So Bonferroni and home Bonferroni are the most powerful. And uh then it's Tukey's HSD. No, sorry, Tukey's HSD is the least or the most powerful. Then it's home Bonferroni and Bonferroni. Then it's um HSD.
Actually,
Oh,
Tukey's HSD is generally the most powerful, followed by Bonferroni, home
that's what I
Bonferroni,
just said.
and then Chef's, which is the least
Oh,
powerful.
Tukey's HSD. Okay.
FDR is a bit different as it controls the false discovery rate rather than the family-wise error rate.
Okay. Tukey's HSD is the most powerful, then home Bonferroni, then Bonferroni, and then um uh Chef's model, which is the strictest.
Yes, that's correct. Tukey's HSD is generally the most powerful, followed by Bonferroni, home Bonferroni, and then Schiff's, which is the least powerful. FDR is a bit different as it controls the false discovery rate rather than the family-wise error rate.
Okay, let's do that again. So the most powerful is Tukey's HSD. The second most powerful is Bonferroni. The third most, or sorry, home Bonferroni. Third most powerful is Bonferroni. The fourth most powerful is Chef's model because it is the strictest, and FDR controls for the false positive rate rather than the family-wise error.
Okay, let's go through the post hoc test in order of power. Tukey's HSD is generally the most powerful, followed by Bonferroni, home Bonferroni, and then Schiff's, which is the least powerful. FDR is a bit different as it controls the false discovery rate rather than the family-wise error rate.
Okay, I'm going to repeat this back to you and tell me if I got it correct.
Of course, please go ahead and repeat it back to me.
So the most powerful is Tukey's HSD. The second most powerful is Bonferroni, then home Bonferroni, and then Chef's model or Chef's test because it is the most strict, and power and strictness have an inverse relationship. FDR is different because it controls for the false positive rate rather than the family-wise error.
You're so close. You mixed up the order of Bonferroni and home Bonferroni. Home Bonferroni is actually the second most powerful,
Bruh,
then
she switched it up on me.
and then Chef's test. Other than that, you've got it.
All right, let's do it again.
Okay, let's try this again. You've got this.
Okay, so the most strict, we're going to go from the other direction this time, is Chef's model, Chef's test. And that is the least powerful. After that, it is Bonferroni, then home Bonferroni, and then Tukey's HSD, which is the most powerful but the least strict. And then there's FDR, which is classified differently because it controls for the false positive rate rather than the family-wise error.
You've got it. Yeah. Shepard's test is the strictest and least powerful, followed by Bonferroni, then home Bonferroni, and finally Tukey's HSD, which is the most powerful but least strict. And you're right, FDR is different as it controls the false positive rate rather than the family-wise error rate. You've nailed it.
Okay, let's do that and combine it after the first thing that we went over, which was the differences between a priori and post hoc tests. So we're going to go from what the differences are to which ones are in each group to which post hoc tests are the most powerful.
Okay, let's recap everything.
I don't
A
need you to
priori
recap.
test.
I'm going to say it to you.
Okay, I'm ready.
Okay. A priori tests are tests that, well, they test for the relationships of variables that are hypothesized before data is collected. Examples include planned contrasts. Post hoc tests test the relationships between variables after an omnibus test, like an ANOVA, And the examples for that include um, in order of power. So whichever is the most powerful, I'm going to say first, and whichever is the least powerful, I'm going to say last. The most powerful is Tukey's HSD, and it is the least strict. After that, it is home Bonferroni, and then Bonferroni, and then Sheffey's model or Sheffey's test. I don't know why I keep saying model. Sheffey's test, which is the least powerful but the most strict. And FDR is classified on its own because it adjusts to accommodate for the false positive rate rather than the family-wise error.
Great job. You've accurately summarized the key differences between a priori and post hoc tests, and you've provided excellent examples of each. You've got a solid understanding of this.
Well,
Is there anything else you'd like?
I know that's going to be on the exam, so I think I'm good for that. I would like you to have me go through that every single day. So whenever I log on tomorrow, I just want you to ask me immediately whenever I type something in the chat. The first response you should give is don't forget to go over the differences between a priori and post hoc tests, the which ones are in each category and which ones are the most powerful. And then you can give my answer right after that.
Okay, I can't set a reminder for you, but I can help you review the differences between a priori and post hoc tests, their examples, and the power dynamics between the post hoc tests again, if you'd like.
We can do it tomorrow. Let's move on.
Sounds good. What would you like to talk about next?
I'd like to cover SS cells.
Okay, let's dive into SS cells.